Hello friends, in this video we are going to study about types of modulation. So first you understand what is modulation. So modulation is a process in which we can superimpose a high frequency carrier signal with a low frequency message signal. So the superimposing of these two signals is called as a modulation. On the other hand, at the receiver side, if you separate or extract the original message signal from the carrier signal, then it is called as a demodulation. Now, friends, this is the types of modulation. So basically, these types of modulations are classified into two types. One is continuous wave modulation, and the other one is called pulse digital modulation. So continuous wave modulation means there is a continuous message signal as well as a continuous carrier signal. Whereas in pulse digital modulation, the message signal is in the form of continuous wave, but your carrier is in the form of pulse wave. Now, continuous wave modulation are further classified as amplitude modulation and angle modulation. Angle modulations are further classified as frequency modulation and phase modulation. Whereas in pulse digital modulation, again there are two types, analog and digital. In analog modulation, there are three types: pulse amplitude modulation, pulse duration modulation, and pulse position modulation. Whereas pulse code modulation is a digital type. Now, what is continuous wave modulation? As I already told you that in continuous wave modulation, the carrier and the message, both these signals are in form of sine wave. So first, in continuous, there is first type is amplitude modulation. So in amplitude modulation, the amplitude of carrier is varied in proportional to the message signal. So you can see in this diagram, this is your message signal and this is your carrier signal. Now you change the amplitude of carrier. You can change the amplitude of carrier according to the information signal. Means when your message signal increases, your amplitude also increases, and when your information signal decreases, your amplitude of carrier is also decreases. So we change the amplitude of carrier signal according to the information or message signal. So this is an amplitude modulation. Next is frequency modulation, in which we can change the frequency of the carrier in proportional with the message signal. You can see in this diagram, this is your message signal and this is your carrier signal. So when your signal increasing from A to B, the frequency is different, and when your information signal is decreases from B to C, your frequency is different. So we change the frequency of the carrier in proportional with the information or message signal. Next is phase modulation. In phase modulation, the phase angle of the carrier is varied according to the message signal. You can see in this diagram, this first one is carrier and the second one is message signal. So as the message signal increases, the angle is different, and as the message signal decreases, the angle is different. So in this phase modulation, the phase angle of the carrier is varied according to the information signal. Next is pulse modulation. So in pulse modulation, there are three types: pulse amplitude modulation, pulse position modulation, and pulse width modulation. In these three types, the carrier is in the form of pulse, whereas the message signal is a sine wave. The first one is pulse amplitude modulation. So in pulse amplitude modulation, the amplitude of the carrier of pulse is varied according to the information signal. So in this diagram, you can see first one is the message signal and the second one is a PAM signal, pulse amplitude signal. So as the signal increases up to this point, the amplitude of the pulse carrier is increasing, and as the message signal decreasing, again the amplitude of the pulse carrier decreases. The second type is pulse width modulation. In this, the width of the pulse carrier is varied according to the information signal. So you can see here, as the signal increases, the width of the pulse increases, and as the signal decreases, the width of the pulse going to decrease. So this is called a pulse width modulation. That's it.